I want now to find C. How can we find C? We said that a width A is, if you have these two axes, and this is our ellipse as an example, we say that this distance is A and this distance is B. How can we find C? He said now, this if the focal, the point, sorry, on the major axis, we called it focus. So a distance from the focus to a point was, we called it C. As we name it with C. So because of that now, let's name it like this, and this will be my ellipse. And we said here, we have an A, B, and B. Now, the distance from the center to A is A. Or from the center to the vertex is A, and to B is B. Now, at the beginning of the lesson, he told me that if there's a point P on an ellipse, okay? He told me now the distance from this point to the first focus and plus the distance from this point to the second focus is equal to A. The distance from P to F1 plus the distance from line segment from P to F2. He told me at the beginning it is K, and this K, it is 2A. So if from P to F1 plus P to F2 is equal to A, okay, can I say now this is, it will be an A, and this one, it will be an A also? I think clearly on the, this one here, it will be clearly here. P to add to the point F1 plus P to the point F2 is equal to 2A. Now, if you look at this triangle here, the smallest one. For the smallest one here, this is a point C, this is a point A, this is a point A also. It makes like this ellipse. Here is A, here is C, here is also C, here is also E, here is B. Now, he told me now, from here to here, the distance, we name it with C. And to B, we name it with B. And he told me that the distance from a point on the y-axis to the C is A. Okay, I want now, using A and B, I want now to find C. Look at this triangle here. It's
We're
like
going to use the Pythagorean theorem.
right triangle. Sorry?
We're going to use the Pythagorean theorem.
Yes. So now it is a right triangle. In the right triangle, all of us know if I want to find A squared, I say it is B squared plus C squared. Is it right? Because it's a right triangle and I will use the Pythagorean theorem. So I need C. Here, the thing I want to do it, that if I have, I mean, all of us know that in the equation, we have A squared. This is y, okay? Over B squared equal 1. So from this equation, I know A and B. But how can I know C? I will use this formula. In this formula, I can say now that C squared is equal A squared minus B squared. If I have A, if I have B from the equation, I can find C using this relationship, that c squared is equal a squared minus b squared. Is it clear?
Yes.
Yes.
Okay. Now let's have an examples. Find the foci of an ellipse. Here now, he told me, I want you to find the foci of an ellipse with an equation 25x squared plus 9y squared equal 225. Graph the foci and the ellipse. So now the first step here, I look at the equation. Look at the equation here. As I told you before, if the coefficients of x and y are not equal, I will say that this is an ellipse. So 25x squared plus 9y squared equal 225. Is this a standard form of the ellipse, of the equation of the ellipse?
No, it's not
Yes.
one.
It will be
No, it's
x
not.
squared over a squared plus or b squared equal y squared over b squared. It must equal 1. But here now it is 225. So how can I make 225 equal 1? By dividing into 225. Is it right?
Yeah.
If I divide 225 and 225, I have 1. And since I divide the term or the right term, I must divide the second term. Let's divide it here also by 225. Then, this now, as you know, in the distributive property, I can now divide the 25x squared over 225, and also I can divide 9y squared into 225, which equal 1 because they cancel each other. Then, after that, let's simplify the first term here. 225 over
It's
25.
x squared over 25, right?
Yeah, I will simplify now them by dividing in 25 in both the numerator and the denominator. So by 25 it is 1, by 25 is 25. So I will say now x squared over 25 plus divide by 9, divide by 9. 225 divided by 9 is 16.
Teacher,
Yes?
225 divided by 25 is 9.
Is 9. It was 625. Thank you. Thank you, honey.
No worries.
So it is 9. Plus 9 over 1, it will be 25. It will be now 1. Now after that, look at the numbers in the denominator. One is 9 and the second is 25. Which is greater?
25.
25. So now 25 is greater than 9. So, and 25 is under y. So the major axis on the y-axis, so it is a vertical ellipse. So I know now it is a vertical ellipse. Let's continue. Now, I need now to find the foci. Okay. From here, what is the value of A? It is the greater
25.
Now, A squared is 25. So A will be
5.
5. So don't forget, A, it will be positive, negative 5. So now, what are the coordinates of the vertices? What will be 0, 5 or 5, 0?
0, 5.
0, 5. Thank you, because I am in a horizontal, in a vertical ellipse. So now I have A. Let's find B. Now from here, B squared is 9. So what is the value of B? B positive, negative 3. So now the vertices is
Negative 3.
it will be 3, 0 and negative 3, 0. So now I have A, I have B. I need now to to find the foci. How can I find the foci? Using C squared equal A squared minus B squared, the previous relation. I have A and I have B. I can find C. Let's now find C.
So the one you are doing is the vertices, right?
Yes, the vertices and the co-vertices. C squared, A squared is 25 from here. Minus B squared is 9. Will be what now? It will be 16. So C squared is 16. So what is now the coordinate of the foci? Yes. What is the coordinate of the foci will be?
0, -4, 0, 4.
No, it will be 0, 4, and 0.
Yeah.
Why? Because I'm in a vertical ellipse. In the vertical ellipse, both of the foci and the vertices is on the y-axis. So by now, I found the coordinates of the vertices, of the co-vertices, and of the foci. I will now can I now graph the ellipse? Yes, let's do it now. So we have vertices 0, 5 and 0, negative 5. And we have a co-vertices that was 3, 0 and negative 3, 0. And we have a foci that was 0, 4 and 0, negative 4. And we say that it is on a vertical ellipse. So now the first step, let's plot the points. 0, 5. So I'm on, sorry. Here I have 1, 2, 3, 4, 5. So here it will be the first vertices. And the second one here, 1, 2, 3, 4, 5. So it is 0, negative 5. Now, the co-vertices, it is on the x-axis. Here was 3, 0. And it was negative 3, 0. Now, the foci. We know that the coordinates of the foci is 0, 4. So it is here. And 4, it was here. Now, after that, I want now to sketch the ellipse. This will be my ellipse. After I found the vertices, the co-vertices, and the foci, I can now draw the ellipse. Is it clear?
Yes, teacher, thank you.
Yes.
Now let's do another example. Got it too. I will repeat the same idea but with the different numbers. Do you have any question here?
No.
No.
Okay. Now, what are the coordinates of the foci of the ellipse with an equation of 36 x squared plus 100 y squared equal 3,600. The first step, as I told you, you have to divide or to make the number here is 1. So 36x squared plus 100 y squared equal 3,600. Then let's divide all of them by this number. So 36x squared over 3,600 plus 100 y squared over 3,600 equal 1. After simplify now,
36 divided equals 0.01.
so now 1 over, x squared over 100 plus y squared over 36 is equal to 1. So now, what is greater, 100 or 36? Which is greater, 100 or 36?
100.
100. And the 100 here, is it under?
It's under X.
Is it under X? So I'm talking about now a horizontal ellipse. Is it right?
Yeah.
Yes. So now let's write the equation here. X squared over 100 plus y squared over 36 equal 1. So from here, now, so a squared is equal 100 and b squared is equal 36. So from here, a it will be 10. So the vertex, the coordinate of the vertices, it will be 10, 0, and negative 10, 0. Why? Because here I'm talking about horizontal. Horizontal ellipse, that's mean the values of A it will be on the X coordinate. Now, B squared is 36. Here, no. Here, the value of B, which is 6, it will be on the
0, negative 6, 0, 6.
Okay? So now, I have now the vertices, the coordinate, of the vertices, the coordinate of the co-vertices. What I need now to graph the ellipse? I need the foci. How can I find the foci? Using this formula.
A squared minus B squared.
Equal A squared minus B squared. Now A squared is 100 minus 36 which is 64. So c squared now is 64. So what is the coordinate of the foci? Look at here now. Look at here now. Look at the ellipse, the vertices, sorry. The vertices in the x. So the foci, it will be on the x2.
Yeah, F0.
And the second one, it will be 0. What am I here? Sarah, Maya, Lama and Lana didn't attend the class. Okay. Sarah, Maya, Yara, Ragad, Haneen, sorry, Habiba. Is this the question clear?
Yeah, it is.
Yeah.
Sarah?
Teacher, I'm here. Yes.
Sarah, is it clear?
Yeah.
Everything is clear. Okay. Lama and Lana didn't attend the class. Okay. So by now, I have now the vertices. Let's write it here. The vertices now is 10, 0, and negative 10, 0. This is the vertices. The co-vertices, it was 0, 6, and 0, negative 6. And the foci is 8, 0, and negative 8, 0. From where I bring this 8, the square root of 64, which is 8. Now, I want now to graph the ellipse.
Teacher, the second one is negative ellipse.
Yes. I wrote it like b over 8 over. Now, let's draw the x and y axis. Now, since I'm talking about horizontal, so the major axis, it will be on the x-axis. Now, let's drop. Now the first one. 1, 2, 3, 4, 5, 6. Okay. Now look at the first one here. Its coordinate is 10, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is here. The second one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is here. What about now the foci? It is an 8, so it will be here and here. Now the B, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now these are our endpoints of the ellipse. Now let's have an ellipse. This is our ellipse now. With the vertices here, it was 10, 0, and negative 10, 0, and here it was 6, 0, 6, and 0, negative 6, and the focus here because of moving the ellipse, it must to be here. So here we have 8, 0, and here we have negative 8, 0 as the coordinate of foci. Is it clear?
Yes, teacher. Thank you.
Yes.
Yes.
Now, in this problem here, this is a widespread gallery, a room with an elliptical ceiling called an ellipsoid, since it is a three-dimensional form. This gallery, thanks to the reflective property of the ellipse, a whispered message on one focus can be heard clearly by someone standing across the room at the other focus. Now, this is words. I want now the math one. If the elliptical ceiling has a major axis of 120 feet and a minor axis of 72. So now, from this, the major axis is 120 and the minor is 72. I want you now, from you, to go back here. Now, you said that this is the major axis. Sorry. This is the major. This is the major axis. And from the center to this vertex is A. And from this center to this another one is also A. So what is the length of the major axis? Or the width, sorry. I will repeat my question.
It is 2A.
Yes, that's it. Here, my ellipse. If it is from the center to this vertex, the distance is A. And from here to here, also the distance is A. So what is the length, the width, sorry, of the major axis? It will be 2A. Is it right?
Yeah.
And look at the minor now. Here we have B, and here we have B. So the length of the minor axis will be
2B.
2B. And if we have now, this focus is here and this focus is here. F1 and F2. Okay, so because of that now, the distance, sorry, the distance now, okay, the distance now from the point, the center to the focus, we name it with C. And here also is C. So if I'm asking you now, what is the distance between the two foci? You have to tell me it is what? It is what? 2C. Okay, here is the foci from the center to the F is C, and from the center to F sub 1 is also C. So the distance, it will be 2C. So the length or the width, sorry, of the major axis is 2A, and the length of the minor axis is 2B, and the distance between the two foci is 2C. Deal?
Yes, teacher.
Yeah. Now let's go back to our question here. Here now, the major axis is 120. And the minor is 72. So I told you now that the length of the major is 2A. The length of the major is 2A. So what A will be?
60.
60. What does it mean? That means this is my ellipse. The distance from this point to this point is 120. From the vertex to another vertex is 120. So from the center to here, it will be 60. That is 120 over 2. So what is the vertices of this? The coordinate here, it will be 60
and -0
and negative 60, 0. Now then, the minor is 72. So this will be 2b. So what is the value of b now? It is 72 over 2, which is?
36.
36.
36.
So here now, we have a 0, 36, and 0, negative 36. Rose, mute your microphone, please.
Oh, sorry, teacher.
So here, B now, it will be 36. So I have now A, I have now B, and I put now its vertices. But what's the question? He asked me now, how far apart are the foci? What is the distance between the two foci? Here now, I want to find the distance from this point to this point. I need now to find the distance between the two foci. How far are the foci? So to find the distance, what did I tell you? That the distance between the two foci is 2c. Is it right? So I need now to find c. Then I multiply it by 2. So now I find the distance between the two foci. So then I go back to this relation. C squared is a squared plus, minus b squared. Where is a squared? Where is a? It is 60. 60 squared minus the value of b is 36 squared. Then after that, 60 squared is 3,600 and 36 squared, wait please, it is 1,296. Then this number minus 3,600. So c squared, after you subtract them, you will find that c squared is equal 2,304. Square root.
Teacher, it is 2,354.
How? I tried in the calculator. Right, please. Two thousand three and 4. Sorry, no, sorry. Square root of the answer. So C now, it will be 48. This is C. So here now, it have to be 48, 0 and negative 48, 0. Then, what is the distance now? Or how far are the foci? Yes, Hausan. I want to hear your voice. What is the distance between the two foci?
It is 2c, so
thank you. So it will be
c is 40.
So the distance is what?
If c is 48, then what is the center?
It's 2c.
Oh,
So it will be 96.
24.
So 2 times 48, which will be
96.
96. This is now how far apart are the foci. Is it clear now?
Yes.
Do you have any question for this lesson?
No, thank you.
No, thank you.
See, you have 10 minutes left, I think. Where's the... Is it right? You must have 10 minutes now left.